So, question 2. The population of a small town was 50,000 at the start of 1996 and doubles every 7 years. So to be clear, our input, which is x, is years, and that is starting at 1996. And then our output, which is y, is the population. Okay? So we're given that x is 0, y is 50,000, 7, 100,000, 14, 200,000, 21, 400,000, 28, 800,000. And the first question is to find the exponential regression. So we're going to do that in the calculator. First thing I like to always do is go to y equals, y equals, y equals. Just make sure that there's nothing in y1, nothing in y2. Make sure your plots are unhighlighted. So for example, if you have a plot that is highlighted like plot 1, go up to it, hit enter. Make sure none of your plots are highlighted. Then we're going to enter the data in the calculator. So we're going to press stat, 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 number 1 for edit, and I'm using list 1 and list 2. So in list 1 I have 0, 7, 14, 21, 28, and in list 2 I have 50,000, 100,000, 200,000, 400,000, 800,000. And to do any of the regressions that are done the same way, we're going to press stat, 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 to the right for calculate, to the right for calculate, and this time we're looking for exponential regression. So we're going to go down to 0, exponential regression. Depending on your calculator, this calculator asks for x and y, so for me, x is list 1, second 1, enter, y is list 2, second 2, enter. If you have the other form of the calculator, then you can put exponential regression, and it's waiting for second 1 for list 1, comma, which is above the 7, comma, which is above the 7, second 2 for list 2. And then when you do that, go down to calculate, notice it's going to give you y equals a plus bx. You need to plug in a for a and b for b. So when we do that, with a little bit of rounding, I'm going to put p for population, we'll use x for years, and that form was 50,000 times 1.104 raised to the x. So that's the equation we'll be using. Now, the next question says we're going to graph it. Well, in order to graph it, we're going to have to sketch it first. So when I sketch it, let's make sure we understand that on the x-axis we have years, on the y-axis we have population. Now we're going to have to figure where to start, where to end. Well, notice that it starts at 0, goes to 28, so I'll start at 0 and I'll go to maybe 35, so I can see a little bit later. And maybe count by 7s, kind of like they did. So 7, 14, 21, 28, 35. Notice the population starts at 50,000 and goes to 800,000. So maybe start at 0, maybe count by 200,000s. And go up to 1 million. So my x-axis is going to go from 0 to 35, counting by 7s. My y-axis is going to go from 0 to 1 million, counting by 200,000s. Now, I could sit here and plot each one. So 0 is 50,000, 7 is 100,000, 14 is 200,000, 21 is 400,000. Sorry, 21 is 400,000. 28 is 800,000. And you kind of see that exponential curve going on, so we can do it like that, and we could do it in the calculator. So again, we do stat, number 1 for edit. We already have our data in the calculator, list 1, list 2. Then we're going to press second y equals, second y equals, second y equals. We're going to do plot 1, turn it on, choose scatter plot, which is the first one. My x is list 1, second 1. My y is list 2, second 2. I like to use the box, so I'll choose the box to show each data point. And then I'm going to press window, 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 and the window we just set, 0 to 35, counting by 7s, 0 to 1 million, 1, 2, 3, 4, 5, 6. I counted by 200,000s. Hit enter, and then hit graph. Notice you get the dots. If you want to see the line as well, we can go to y equals, and let's put the equation in there. 50,000 times 1.104 raised to the x, and that line will go through the data. Okay, so we get the dots, and we get the line that goes through it. Now we're going to use that equation to answer a couple questions. So the first one says, use the equation, the exponential equation, to find out the population, total population, at 4. So that means we're just going to plug 4 into the original. So that would be 50,000 times 1.104 raised to the 4. Now again, I can just type it in to the calculator. I can put second mode, go to the home screen, 50,000 times 1.104 raised to the 4, and I would get the population, total population, of 74,276, if we round off. So that would be 74,276 would be the population. We'll write the sentence in the middle. Or we can also use the table feature. So remember, your table needs to be set up. If you hit second window, make sure independent is ask is highlighted, press enter on ask, and dependent is auto, press enter on auto. Then go to the graph, second graph for the table, second graph for the table. Delete anything else you got in there. And if I plug in 4, it gives me the same answer, 74,276. So we're just plugging in the original, so that would be at year 4, the total population is 74,276 people. Okay, so we stopped at year 4. How many people do we have right now? 74,276. Now we're going to take the derivative. So the original, P of x was x, equals 50,000 times 1.104 raised to the x. Now, when we look at this, it's a special case. It is a number raised to a variable. So how do we do? 50,000 stays in front. How do we take a derivative of a number raised to a variable? Step 1, rewrite it. Step 2, ln of the base, 1.104. Step 3, derivative of the exponent. Derivative of 1x is just 1. So when I clean that up, 50,000 times 1 is just 50,000 times 1.104 raised to the x times ln of 1.04. So we found our derivative. Now we're going to plug 4 into the derivative and figure out what that is. So P derivative of 4 equals 50,000 times 1.104 raised to the 4 times ln of 1.104. I'm going to just put that in the calculator, and then we'll do it in the table as well. So again, you could just type it in, hit second mode to go back to the home screen. 50,000 times 1.104 raised to the 4, move to the right, times ln of 1.104, close parentheses, and you should get 7,348.8, so round that off to 7,349. 7,349. We'll explain it in a minute. But how can I do this in the calculator? In the calculator, we go to y equals, and remember, we can put the derivative in the calculator, y2, and our derivative in y3. So how do we do it in the calculator? When you go to y2, hit math, number 8 for derivative. Now if your calculator looks like mine, it's x, and then in the inside parentheses, we're going to put y1. So we're going to hit vars, to the right for y vars, to the right for y vars, number 1 for function, choose y1 by pressing 1, choose y1 by pressing 1, press to the right, x. If you have if you have the other form of the calculator, it may ask you like n derivative, and then kind of parenthesis weighting. You would put y1, just like we did, vars to the right for y vars, function 1, y1, comma above the 7, x, comma above the 7, x. Same thing, just a different way to type it in. And then let's put our derivative in y3 to see if we did it correctly. 50,000 times 1.104 raised to the x move to the right, times ln of 1.104. Now what's nice of doing this in the calculator, close parentheses, is that now y2 and y3 should match. So we go to second graph. Notice y2 and y3 match. When we plug in 4, that means everything is correct. So when we write this up, it would be at year 4. How is the population changing? The population is increasing. How do I know it's increasing? Because it's positive 7,349 people per year. So at year 4, the population is increasing 7,349 people per